Okay, today we're going to start our lesson on limits with tables and graphs. A limit is a concept where we're looking at a function and asking, as x approaches some constant number here, does it approach to a single number of n there? Just give me 1 second. Alright, my cord was caught. Alright, so let's try it with the table. I'm given a function 3x plus 1. I want to know, does the limit exist as x is approaching 2? We're just getting these numbers from the calculator right now. So I've got 6.4, 6.7, 6.97, 7.03, 7.3, 7.6. So those numbers we're just evaluating from the calculator. We're looking from the left side of 2 and the right side of 2 is where we're approaching. Are we coming to the same number? And the answer is yes. They're both converging on 7, so the limit as x approaches 2 would be 7. For example, number 2, we have 5.4, 5.7, 5.85, 6.15, 6.3, 6.6. And again, we're looking for this limit as x is approaching 1. So as x is approaching 1 from the left and from the right, are they coming to the same number? And the answer here again is yes. They're all heading towards 6. We could also look at limits through graphs. All right, so we have, what is this limit here as x is approaching 2? So as x is approaching 2 here, I'm looking at the graph from the left and coming in from the right. They're all converging on the same number, and here our answer would be 1. Problem 2 says, what is the limit as x is approaching -1? So -1 is here. I look from the left side and from the right side. They're all coming to the same place, and that would be -3. So the limit there is -3. Now the next problem is a little bit more interesting. It asks, what is the limit as x is approaching 3, which is right over here. And we can see the graph is clearly discontinuous. However, as I approach 3 from the left and from the right, a limit does exist because they're both coming to the same number, and the answer would be 2. So the limit here is 2. However, if I asked you to evaluate the function at 3, you would have to tell me what the output value is, and in that case it's -1. So the limit and the evaluation at the same number does have the potential to be two different numbers. Limits also do not have to exist. If they do not exist, we write D and E for does not exist. So let's look at this graph here. I'm just going to have to make some numbers up for output values. Any test you have will be perfectly clear. Alright, so I want to know, what is the limit as x is approaching -1? Looking at it from the left and from the right. While there's a hole in the graph, they are coming to the same number, so we would say here that the limit is 3. Now, on the other side of that, I want to know, what is the limit as x is approaching 2? Coming from this side, we're here, over here. There's a big gap in between where those two graphs are headed, so in this case, the limit does not exist. We may be asking you to make your own graph, so please get them correct. We have a vertical asymptote coming from the denominator here. This one also has a horizontal asymptote here for this rational function. And the graph would look like this. Okay, so then it asks, all right, what is the limit as x is approaching 1? As I'm approaching 1 from this side, my graph is heading towards -infinity, and from this side it's heading up towards +infinity. So we would say, also for this one, does not exist. All right, let's try a piecewise function. Let's flip those papers over. Graphing our piecewise function, we have where x is existing less than 1, our basic parabola of x squared. We do have a solid dot here because of the or equal to. And this guy would look like this. On the other side of 1, we have a linear equation. So we start at -3, but the graph doesn't pick up till we get to 1, so up to over 1. We'd have an open circle here because we do not have the or equal to. Up to over 1, up to over 1. So this guy would look like this. And it's asking what is the limit as x is approaching 1. So as we're approaching 1 from this side, we wind up here at positive 1. As I approach 1 from this side, I'm at negative 1. They're not in agreement with each other, so we would have to say does not exist. Problem 11 says, can you change the problem to make a limit exist? I'm going to change that to something real simple, just your basic linear function of x. So I would pick up here, up 1 over 1, pick up here, up 1 over 1. Now, if I looked at it, approaching 1, we are coming to the same number, and our answer would be 1 there. The extra problems on this paper are just a check for understanding. Why don't you go ahead and give those a try at home, and you can check your answers with the key and vision. And we will pick up on 10.2 next time.